Continuing with the chemical reactions of alcohols and also reaction of alcohols with hydrogen halides, let's go ahead. Now we are still doing reaction with hydrogen halides, and we shall go ahead and have a look at the reaction with conc HBr. Now ROH plus conc HBr. But how does this HBr get produced? So HBr is produced by the reaction of NaBr and H2SO4. Let us see how does this take place. So NaBr, when made to react with H2SO4, it gives out HBr, and along with that what we get is NaHSO4, that is sodium bisulfate. So when ROH is made to react with conc HBr, there is loss of water molecule, and the product that we get is RBr, that is an alkyl bromide. Let us have a look at its reactions. Before the reaction, we must again see the reactivity order, which is 3 degree, greater than 2 degree, greater than 1 degree. So this again suggests to us that the conditions required for 1 degree to react would be the harshest, and for 3 degree to react would be the easiest. Let's begin with 1 degree alcohol, and the example that we have here is ethyl alcohol. When ethyl alcohol is made to react with HBr, which is produced by the reaction of NaBr and conc H2SO4, there is loss of water molecule, and what we are left behind with is C2H5Br, that is ethyl bromide. Now when we go to the next condition, that is secondary alcohol, we take the example of isopropyl alcohol and make it react with conc HBr. The conc HBr is produced by the reaction of NaBr and dilute H2SO4 this time instead of concentrated, because doing this reaction is easier. So we again lose water molecule and we are left behind with isopropyl bromide. Next and the last example that we have in this category is 3 degree alcohol. When tertiary butyl alcohol is made to react with conc HBr in the presence of again NaBr and dilute H2SO4, water molecule is eliminated with the production of tertiary butyl bromide. So this was about the reaction with conc HBr. Moving ahead, let us have a look at the reaction with conc HI. Now ROH, when reacted with conc HI in the presence of phosphoric acid, water molecule is eliminated with the formation of alkyl iodide, that is Ri. Now here again the order of reactivity is 3 degree, greater than 2 degree, greater than 1 degree. Also the order of halides here is HI greater than HBr, greater than HCl. That means that since we are using HI, the condition required as compared to HBr and HCl would be the mildest. And in this particular category, 1 degree would require the harshest of the conditions and 3 degree would require the easiest of the conditions. So first 1 degree example is ethyl alcohol, and when it is made to react with conc HI, it requires the presence of H3PO4. Again, water molecule is eliminated and we get the product that is ethyl iodide, or in IUPAC terms, iodoethane. 2 degree should be simpler to perform. We have isopropyl iodide in the presence of HI. It is made to react with it, and the product that we get is again isopropyl iodide and water. The last one that we have is tertiary alcohol. We take tertiary butyl alcohol and we react it with conc HI. No other reagent or catalyst is required. There is elimination of water molecule, and the product that we get is tertiary butyl iodide. Let us summarize all these reactions in one go. So we have this table in front of us which has alcohols 1 degree, 2 degree, 3 degree, and all the 3 hydrogen halides HCl, HBr and HI. 1 degree is the least reactive and 3 degree is the most reactive. So when you take conc HCl, 1 degree requires anhydrous ZnCl2 and heat, 2 degree requires only anhydrous ZnCl2, whereas 3 degree reacts at room temperature without the help of any catalyst. Conc HBr on the other side requires conc H2SO4 for 1 degree, dilute H2SO4 for both 2 degree and 3 degrees. When it comes to HI, which is the most reactive, for 1 degree we require the presence of H3PO4, whereas for 2 degree and 3 degree no such requirement is used. So moving ahead, let us solve a very interesting example. Find the product for the following reaction. We have this here and it is made to react with HI. It's very simple. H from HI react with OH from alcohol to form H2O, and in place of OH we just placed iodine. But this is the wrong answer. This is not the correct answer. So what is the correct answer? Let us find it mechanistically. Step 1. The alcohol is protonated by acid. Since we have HI dissociates to give H plus and I minus. This H plus in turn protonates the acid. H plus is attacked by the lone pair from OH, and thus we get protonated alcohol. Oxygen here has a positive charge and is highly unstable. So in the next step, we have the formation of carbocation by the elimination of water molecule. Now this results in the elimination of water molecule and we get a 2-degree or secondary carbocation. Now in the third step, what happens is we have hydride shift for the formation of stable 3-degree carbocation to give a tertiary alkyl halide. We have this 2-degree carbocation and there is something called as hydride shift, that is H from the tertiary carbon goes to the CH plus carbon and leaving us behind with a tertiary carbocation, and tertiary carbocation is more stable than a secondary carbocation. Now since the positive charge is on the tertiary carbocation and it is the most stable, it is attacked by I minus, giving us this product. So in short, when we say that if someone asks you this question directly, that you're supposed to react the given alcohol with HI, you will not simply replace OH by I, but in fact I would go to the tertiary carbocation instead of the secondary carbon atom. So the product that we see here is the final product. So this was about the reaction of alcohols with hydrogen halides.